The Thermal View survey software has been developed and designed to address all of the challenges you will face as part of a temperature uniformity survey pyrometry test for AMS 2750 or CQI9. What I'd like to do now is review some of the features and benefits of the software to help you review, interpret and analyze the data that you're getting from the survey test you've run. On the screen in front of us now, you can see the graphical view of a TUS performed at one particular temperature level. You'll notice that the overshoot search, the stabilize and the survey time are color-coded pink, gray and green. These have been adjusted by the user to fit the data, and they are proving that the data is falling within the acceptable tolerance. In the temperature data analysis tab, you'll see that the zones are color-coded to match the raw data. So you can see exactly the numerical values of each and every data point for each of the 10 channels that were used in the 3 respective zones of the TUS that's performed. If the TUS was unsuccessful, and for instance, if one of the thermocouple traces actually exceeded the upper tolerance limit, 800 plus or minus 14, so 114 degrees or even higher, you'd have what we refer to as an overshoot. The software will detect an overshoot by showing the 3 zones in red completely, and it will actually label the scenario and tell you that you've got an overshoot occurring. The numerical data in the temperature data tab will all be shown in red, and the data that falls outside of the acceptable tolerance would be highlighted in white, so you can identify exactly where on your TUS level you're actually failing the TUS criteria. In the analysis features provided in the software, we have our view frame option, which shows you where the thermocouples are located. But as we saw in a previous video where we could collect the real-time data, the view frame also comes with a neat feature in so much that it tells you the numerical value of each and every thermocouple at the position where the cursor is on the trace. So if you move the cursor across the 3 zones of your TUS, it will actually show you the numerical value of each and every thermocouple, but it will also color code it. So in this case, where the cursor is positioned at the moment, there are 4 thermocouples highlighted in black that have not yet achieved the minimum lower TUS level. Those in green have reached that acceptable level or above and fall within the acceptable tolerance band. If we have an overshoot, as previously on the previous slide, these cells would turn red and the numerical values reported would be in white to show you that you'd exceeded the upper limit, producing what we refer to as an overshoot or a fail. Probably the most important data set for the temperature uniformity survey is what we refer to as the TUS results. So if you go to the TUS results tab, this gives you a tabulated set of data taken from the 3 zones of the TUS for the number of channels that are being used. One thing to note, you have to select the temperature of the TUS that you're performing. So in this case, where we had 3 levels of TUS, I've selected the TUS at 800, the lowest level. The table gives us for each and every thermocouple a set of data taken directly from the TUS levels and the TUS zones. For the TUS time, so the green area, which is probably the most important for our TUS, for each thermocouple we have the minimum temperature, the maximum temperature, the actual deviation from the set point temperature that we're trying to achieve, in this case 800 degrees, and the difference between the maximum and minimum temperature. These are critical criteria that are required by the AMS 2750 reporting list in the document. In addition to that, over the entire TUS, we have the maximum temperature that is achieved for the 3 zones. At the moment, that's recorded as 808 degrees, and that can be used as part of the furnace class calculation. The bottom level or row of the table reports the furnace class if we've applied the furnace class calculation to the data as described in a previous video. The lowest temperature for all of the thermocouples is highlighted in blue, and the maximum temperature of all the thermocouples is highlighted in orange, both for the TUS time and also over the entire TUS. All of this data allows you to fully describe your TUS and quantify the success of the TUS at each and every TUS level that has been performed. So, obviously, when you're performing a TUS, the ideal situation is to obtain a pass, and as I've described previously, that will result in clearly being able to see that all of the channels, all of the thermocouples fall within the tolerance bands. You've got acceptable data in your view temperature data table, and on the analysis table results, it will actually show you that you've achieved all the critical requirements. There's no overshoot and there's no stabilization fail. So in this case, we've got green ticks to illustrate that we have a successful TUS being performed. If the TUS has failed, for instance, in an overshoot, the software clearly shows you that failure with a red graphic view, a label of the overshoot and at what temperature it occurred. Even in the results table, you'll see any data that exceeds the upper limit or if there's an undershoot will be highlighted in that table. And the summary of the results in the results table printout and in the software itself will indicate, as shown here, that we've got an overshoot or a stabilization fail for the data set that we've been analyzing. So all of the hard work that you have as part of a TUS is satisfied with the analysis tools, reporting tools, and reviewing tools that is supplied within the software. So let us now review, using the actual thermal view survey software, the features that we've just briefly summarized in the first part of this video. As you can see clearly on the screen at the moment, we're looking at the first TUS level at 800 degrees plus or minus 14 degrees. You can see clearly from the graphics that all of the 10 channels fall neatly within the tolerance bands, meaning that we've passed this particular TUS. You notice the cursor in the middle of the screen. I can scroll this across the data, and it then shows me the data for each sample interval that was used in the survey itself. In the overshoot search, the pink area, if I move into the grey, I then get the data for the grey zone, the stabilize, and then last but not least, the actual TUS time itself with the green zone. So you can clearly see all of the data that makes up the TUS analysis at that particular single level. If I click on the view frame, as we've saw before, you'll see the frame showing you where the thermocouples are located. But the neat thing is that, again, we can scroll across the graph and you can see at the moment where the cursor is positioned, all of the traces are displayed as black. That indicates that none of the thermocouples at that particular moment in time in the overshoot search have achieved the minimum lower tolerance band. If I scroll across there, you'll see that some of the thermocouples then enter that band and they start to appear as green. And as I keep scrolling, more and more of the thermocouples enter the acceptable TUS until the point where we only have one thermocouple that is outside of the tolerance band, the purple one. If I scroll across even more though, eventually that thermocouple will come into tolerance, and therefore all of the traces are then shown in green, and you can see they are clearly within the upper and lower acceptable limits. Probably the most important tab that we're going to use in a survey is the summary tab, or the results tab as we call it. At the moment I'm looking at the TUS level at 800 degrees, but I can click on the top box and choose whichever TUS level that I may want to review, 800, 945 or 1020 degrees. Let's stick with the 800 degrees. It gives me the TUS level, temperature, and the time period for the green section, which was 30 minutes, which is the recommended period for the TUS. We have the 10 or the 9 thermocouples that we use for the TUS, and then we have all the summary data for each one of those thermocouples over the TUS period. First of all, we focus on the TUS time, the green area. We have the minimum temperature for each channel, the maximum temperature, the deviation from 800 degrees for each of the thermocouples, and the difference then between the maximum and minimum temperature for each channel. Also, the maximum difference over all sensors, which is the lowest and the hottest for all of the 9 thermocouples, and what the deviation is between the two. Over the entire TUS, including the overshoot search, we also record the maximum temperature, and because we've applied the furnace class calculation to this analysis, we also quote what furnace class we've achieved, which is class 5, which is plus or minus 14 degrees. We've achieved that tolerance using the match TUS level applied method, which we talked about in a previous video. So we summarize all of the data in a nice, neat table, and that is then replicated in the full report. That is then your visual documented evidence of the success of the TUS itself. If I now move on to an alternative scenario where we have an overshoot. Okay, let me pick this second level. So we're doing a TUS now at 945 degrees. If I go to the TUS results and I pick 945, because that's the TUS we're looking at, you'll now see that the data set is very, very different because we've failed. You'll notice that on the graph we've got all 3 zones in red, and there's a label indicating that we've overshot, or we've had an overshoot situation at 945, which means that some of the data has exceeded the upper line of the trace. You can see there that we've got a breakthrough at the upper tolerance. In the table, you'll see there that the overshoot is clearly indicated in red. So at channel 5, channel 8, and channel 9, it gives you the actual maximum that was achieved, which is above the upper limit, and how much we overshot by, in this case, 1.1 degrees, 0.6 degrees, and 1.6 degrees. In the temperature data table, you'll see that all of the data is in red, and the thermocouples that have failed at the point where the cursor is and in that vicinity are shown in white. So these are the values that exceed that upper limit of 955. And in the TUS frame, again, if I go to the full zoom, I go take the cursor, you can see there again, if I zoom in, you can see that the overshoot has been highlighted again in red to show that thermocouples have exceeded the upper acceptable limit for that TUS at 945 degrees. So in summary, the software gives you all of the analysis power you need, but hopefully showing how easy it is to set up, analyze, and interpret, and come to a quick conclusion will provide you with an easy way of providing the certified and traceable evidence that your furnace is working to specification.